Let's solve this Thevenin resistor. We're gonna find the maximum power for the load. So first thing first, we need to label A and B. I'm gonna do two methods. One is the Thevenin method, and the other one is the Norton. Alright, I hope I'm spelling them correctly. Let's go ahead and do the Thevenin method first. So for Thevenin method, in order to find the, I'm going to put here. In order to find RT, we will need to short any voltage source, open any current source. So in this case, we only got a voltage source, so let's go ahead and short it. But first, let's go ahead and simplify this circuit a lot better. So over here, we have a 10 volt going up and going down. Next, our first pit stop is this little square over here. Let's go ahead and draw this 20 ohms. Which 20 ohms is this? Is this 20 ohms. Alright? So from this, we can see that it goes towards a 5 ohms. So let's go ahead and draw this into a 5 ohms. And this 5 ohms will go into another pit stop. This pit stop will then go towards the 10 ohms and then to point A. And then we can see that from this pit stop, it goes down to a 20 ohms. And this 20 ohms goes down to a pit stop, and this pit stop is actually connected from the with the first 20. So you can see that it's over here. So essentially, you can say I can draw this line here, but instead of drawing this, let's Pythagoras that bad boy. There you go. You know, Pythagoras. You get it? Yeah, I hope you get it. So now that we have Pythagoras that bad boy, let's go ahead and draw the last line, which is this line over here. And this is our circuit. As you can see, it's very, very simplified and very simple. One good way I like to tell my friends how to see is, every time you see this little black dot as a connector, try to imagine them as like multiple wires clustered up together, and you just need to be able to separate them. Cause like for example, or see them as sliders. So this one you can slide along this whole line, you know what I'm saying? You can slide along this whole line. So this pit, you can slide along this whole line. So this way it's much easier for you to visualize and draw it out. Back to the question. So now that we have shorted our circuit, I'm just going to draw a very simplified version. We have a 5 ohms, 10 ohms, coming down we have a 20 ohms, and we shorted it like this. Alright, and then over here, if I were to put like a multimeter, what is the resistance measured? Now notice why I didn't draw the other 20 ohms here, okay? It's because you realize when I shorted the voltage source, the current would rather take the one without a resistor, the path without a resistor. So in this case, the 20 actually just got quote unquote removed. So yeah, so in the end it will look like this. So this 5 and this 20, it is a parallel circuit. So in this case, the 5 and the 20 will become 5 and 20 plus 10 is basically 4 plus 10 equals to 14 ohms. So this is our Thevenin resistor. How about our Thevenin voltage? So Thevenin voltage is basically, I were to put a ohms meter, I were to put an ohms meter over here. So what would a voltage give me? Did I say ohms meter? Sorry, voltmeter. If I were to put a voltmeter, what will my voltmeter reading be? So very, very simple. Let's see how can we do this. So we can see that here goes to a 10 volt and here goes to a 10 volt. And then this is technically, because this 10 is not connected to any circuit, or rather it's not connected to a place that ends off with ground, because if I were to put a voltmeter here, you know, current technically can't pass through because my voltmeter will have infinite resistance, basically as good as open circuit. So since my current cannot continue his path here, it will never even go into the 10 ohms. So essentially my current will then just go into the 20 ohms and then go to the ground. Okay, ground like being back to the voltage source. So really, if I were to look at it that way, this whole thing is just like a wire that's connecting to my voltmeter. So essentially I'm just getting the voltage of this guy. And in this case, this becomes a series circuit between the 5 ohms and the 20 ohms. So this just means that I will need to find the voltage on the 20 ohms. So this means that my voltage is now 20 over 20 plus 5 times 10, which will give me 20 over 25 is 8 voltage. Am I right? I'm not that confident actually. Yep, 8 voltage. So there you have it. So this is my Thevenin equivalent circuit. So it's essentially just 14 ohms with a load connected here, R load, and then this voltage source is 8 ohms. So if I want to find maximum power is basically what is the power of this guy. Really, it's just like that. So if I recall correctly, based on the module, the notes tells us that maximum power equals to something like the voltage source to the power of 2 times 4 of resistor of Thevenin, because your load resistor must equals to the Thevenin equivalent resistor because of certain formulas. But then how I like to tell myself is basically essentially I am just finding the power of my resistor load, or of my load. So essentially power, I know that is equals to V over I, and then equals to like what, V square over R, or something like I square over R of this particular boy. So since I know that for maximum power, this guy should already be 14 ohms, but this guy is not 8 volts. Since this 14 and 14 is split equally, I know that this guy will have 4 volts. So essentially my power, I can use this formula to get 4 square over 14, and that should give me the same answer. 4 square is just 16, 16 divided by 14 will give me 1.143 watt. If I were to use this formula, same thing, is 8 square over 4 times 14, that will give me 1.143 watts. This means that my theory checks out. Now we shall do the Norton example. So the Norton, same thing. Let's go ahead and do I have, yep, I do have it. Okay, so for the Norton, it's pretty straightforward as well. So Norton, we have to find the current, or let's find the resistor equivalent. Maybe I shouldn't even use TH because it's Norton. Okay, so same thing, short the voltage source. You will see that your resistor essentially also equals to 14 ohms. Now the thing is, how do we find the current? So Norton tells us that we have to combine these two and essentially put like a ammeter. Okay, so this means that this circuit will now form a complete circuit with the 10 ohms, meaning the 10 ohms is into consideration. So let me just go ahead and redraw. So we have a 10 volt to a 20 to a 5 to a 20 and then to a 10. And then there's a, oops, There should be an ammeter over here. So essentially what I'm finding is the current going through the 10 ohms. So we know that this one will have a 10 volts going in here, but 10 volts will not be coming out here, but we know that the voltage will then later split into these two. So we just need to find the voltage going into the 20 volts. So what we have to do is first find these two resistor. So resistor of the 10 parallel to 20 equals to 200 divided by 30 will give me 20 over 3 ohms. So this, and then this 20 over 3 ohms is in series with the 5, but we don't really need to let's cut step, okay? So in order to find the voltage going into the source, we just take 10 volts times the voltage that we want to find going into the particular line, aka these arrows, divided by 20 over 3 plus 5. So you will notice that you get 10 times, I'm punching in my calculator, plus 5, you will get 40 over 7 volts. 40 over 7 volts, so my current going through this ammeter, or rather the current that my ammeter will be reading, is just V over R, which is equals to the 40 over 7 divided by the R, which is 10, and that will give me 4 over 7 amperes. And this is my IN. Notice how for the Thevenin equivalent, I'm just going to go ahead and draw it out again. It's basically your voltage source connected to your R equivalent, connected to your R load. Everything is in series. But for Norton, take note that now is slightly different. It's going to be everything in parallel. So this one will be 14, which is essentially your R, yeah, you get it. And then this one will be your RL. Same principle, okay? Same principle. I want to find maximum power, essentially just the power of this guy over here. So because this is the current will split, and since both of them equals, in order to get the maximum power, I know that the current flowing into this, I just take it as divide by 2 equals to 2 over 7. So power equals to I square over times R, which is 2 over 7 square times the 14. And I hope that I am correct. Yep. Oh, I pressed the eraser. 1.143 watts. And there you have it. This is how you solve to find maximum power, be it the Thevenin or the Norton method.